Hello everyone. So today we're going to talk about the derivative rules. Okay, so far we've been computing the derivative function or the derivative of a function at a point using the limit definition of the derivative, right? So we had those two equivalent forms of the limit definition of the derivative at a point to find, f prime of 2 for a given function f. But we also had the limit definition of the derivative function, right, to find the actual derivative function for a given function. And a lot of the times, right, limits are nice and they're beautiful, but it takes a while to get the actual answer, right? A lot of computation is going on there. So thankfully, so we don't have to keep doing a lot of those computations, mathematicians have proven some derivative rules for computing the derivative function. All right, so this is really great for us mathematicians, especially with functions that are really disgusting looking, right? So a lot of the times I just had you compute the derivative function for something like f of x equals x squared. But what if I gave you like the square root of x plus 1 plus e to the x plus ln of x plus 2 or something? That would be terrible using the limit definition of the derivative, right? So we will use these rules and have these rules, but I do want to caution you to not forget the limit definition of the derivative, all right, because that is in fact the formal definition of the derivative and still very important to understand what it is and how to use it. Okay, so here are our derivative rules. So the first one just says that if k is a constant function, then the derivative of k is just 0. Alright, so that's what these like brackets here and the little tick mark means. It just means I'm taking the derivative of k. And these little tick marks, like f prime of x, that's Newton's notation. Alright, soon we will talk about another mathematician that did invent calculus also around the same time as Newton. He has a different notation, and we will talk about that soon, but not quite right now. Okay, so the main idea here is that the derivative of a number is 0. Okay, that's basically what the first rule is saying. All right, if we have k times x, the derivative of that is just k, where k is a constant. Okay, so for example, the derivative of 2x is just 2. Okay, because I'm basically just saying the number in front of x, the derivative of the number times x is just the number. Okay, and then I might as well just give you a concrete example for the first one. So I don't know, the derivative of 100 is 0. Okay. The third rule here is what we call the power rule. So what it says that it is if n is any real number, then x to a power, or x to the n, the derivative of it, is n times x to the n minus 1. Okay, so basically what happens is you bring down the power, copy the x variable, and then it's just to the power minus 1. So an example would be something like x cubed, right? The derivative of x cubed, bring down the 3, copy the x, and then it's to the power minus 1, so x squared. Oops, I don't know why I wrote the brackets, sorry. So there we go. So the derivative of x cubed is 3x squared. Okay, and then 4 through 6 is just saying that if I have two functions f and g that are differentiable functions and k is a constant, then we have the following. So here I'm just saying that if you have a number times a function, then the derivative of a number times a function is equal to copy the number times the derivative of the function. Okay, and then 4 and 5 are basically just saying that if you have a sum or difference of functions, the derivative of the sum and difference of those functions is just the derivative of the first plus or minus the derivative of the second. Okay, so we'll see these more in action just looking at these next practice problems here. So it says here that I just want to compute the derivative function for the following functions. So, looking at part A, what is f prime of x? All right, well, f of x is just a number, right? It's a constant function. So the derivative is just going to be 0, right? This is our first rule. So the derivative is 0 by rule 1. Okay, what about in part B? I have f of x is equal to e. Well, remember, e is just a number, right? Note, e is approximately 2.718. Okay, so in other words, e is a number. Okay, so when I'm taking the derivative here, then it's just going to be the same thing as part A. The derivative function is just 0, and this is by rule 1. Okay, what about part C? I have f of x is equal to 2x. So here, this would be using rule 2. I'm just going to say the derivative is just equal to 2 by rule 2. Okay, and then what about part D? Well, in part D, I have a power, right? I have x to a power. So this is what we call the power rule, right? So what we're going to do is we're going to bring down the power, which is -7, copy the x to -7 minus 1. So this is -7x to the -8. Okay, so you want to be careful here with negative powers. A lot of times when you get fast with this, you're going to subtract 1 in your head, and you're going to notice that the power always goes down by 1, right? Because you're subtracting 1. And students sometimes just sort of make this mistake where they say that it's x to the -6 instead of -8. So I do caution you with negative exponents to just be careful with that in your head. Okay, and then in part E, I have a sum and difference, right, of functions here. So I have a lot of different things going on. So what I do want to address first, okay, is I just want to take the derivative of each piece. Okay, so I have my pieces here, right? So what I'm going to do is I'm going to say that by rules 5 and 6, this is the derivative of the first function minus the derivative of the second function plus the derivative of the third. Okay, so notice how I just copied these minus and pluses. So you just copy those signs and take the derivative of each piece. Okay, so now looking at the first piece, I have 3 times x squared. Okay, so this would be rule 4, right? I have a number times a function. So I'm going to copy the number times the derivative of the function minus the derivative of 4x is just 4, and then the derivative of a number is just 0. Okay, and then here I just want to let you know that, again, this was by rules 5 and 6 to get to the first line. Okay, and then the second line from there, we used a lot of different rules, but hopefully you see what I'm talking about. Okay, and then the last line here, I'm just to find out the derivative of x squared, I'm just going to use the power rule. So this is 3 times, bring down the 2, copy the x to the 2 minus 1, minus 4. So this is just going to be 3 times 2x minus 4, which is just 6x minus 4. Okay, so I did show out a lot of steps here. Eventually, when you do get better with this, when you get more practice, you'll probably be able to do this computation in your head. But since you guys are just learning these rules, I do want to see these steps written out for now. So just FYI in the first class practice, but eventually, yes, in the course, I do notice that students do this in their head pretty easily. And so eventually, yes, you don't really need to show work for how you're taking the derivative of a function like this. But for now, I do want to see it.